Welcome back, everyone, to Big Data Days 2022. My name is Jeremy, and I'll be the host for this session. It's my pleasure to welcome our last speaker for this event, Nathaniel. He is a senior software engineer from Ripple, and today he will talk about orchestrating DBT transformation with GitLab CI/CD. Utilizing the previous work the Ripple data team built around GitOps and managed deployments, Nathaniel provides a template for orchestrating DBT models. This talk goes through how to orchestrate data build tool in GCP Cloud Composer with Kubernetes Pod Operator as our Airflow scheduling tool that isolates packages and discuss how this benefits the Ripple team from crypto payments and compliance. So Nathaniel, whenever you're ready, the floor is yours.
Great. Hey, thank you, Jeremy. Thanks everyone for joining this session on orchestrating data build tool transformations, DBT, with GitLab CI/CD. This is a 200, 300 level talk that discusses what our team, our data team here at Ripple utilize to orchestrate the production of our data models for the business. So just a bit about myself. I am a data engineer at Ripple, where I focus on constructing and maintaining our data operations and data platform infrastructure. So there's lots of DevOps that gets conducted within the data platform team. I was previously at Microsoft with a focus on distributed systems, monolithic migrations to microservices, and automation of like orchestration engines like Kubernetes. And then in my spare time, I'm a big Web3 enthusiast with a ton of interest around decentralized autonomous organizations, smart contracts, decentralized apps. I previously did some neurotech research around brain-machine interfaces, and then some of my hobbies include, jazz, Charlie Parker, Volume One, vinyl that contains one of the most difficult jazz pieces to play, Confirmation. So let's jump in. I'll start by talking about the data modeling problem that we were facing back in 2020, 2019 at scale as our team needed to ramp up to meet the business needs of the data analytics team. Then I'll walk through briefly data build tool, specifically the DBT CLI, and why we chose to go that direction for our data models. And then the bulk of this presentation walks through how we utilize GitOps, CI/CD, and additional open source tooling to orchestrate DBT to operate with our data warehouse on GCP. So some context to start, what is Ripple? If you're unfamiliar with what Ripple does, we're building crypto financial solutions to manage digital assets. Essentially, we're utilizing the blockchain technology to exchange the movement of digital values on the XRP ledger. So a base example of this would be you're sending you 100 US dollars to a different geolocation. Ripple has product lineups to enable real-time payments and liquidity, leveraging the XRP ledger to send funds rather than historical fiat systems that could take 7 to 10 business days. Now you're able to clear those transactions in about 5 minutes. And since we deal with moving markets, there's a lot of high volume of transaction activity. And our business data analytics teams requires robustness to fit the scale of the business as we onboard new entities. So one of the common use cases of data science teams would be, anomaly detection, auditing, archiving data, compliance, and in the future, what we're looking to specifically in our organization is predictive markets to provide the best rates for XRP exchanges. But we are still considered a startup, and our data sets and tables are shifting as our business does. And the data engineering team is responsible for producing those data models. So data models, again, just for leveling the playing field, represents the framework of what the relationships exist within the database. It provides the structure of what the analytical decisions that the business needs. This is basically a shell that gets stored within the framework of your SQL data warehouse. And then you populate the model with the sources in that warehouse. So a data engineer or a database engineer will vet the data model before deploying to the business because it could determine how costly your warehouse becomes, or if you have to reshape your model because you have a missing dimension, right? Um, but designing these models can be problematic. Collaboration can also be difficult as typically engineers, when within our team back in 2019, we were using local machines to test the integrity of the model. And documentation may not exist from prior iterations or maybe from legacy code. And we also don't have an understanding of how costly these models will be when we produce them onto our data warehouse, right? So, um, we started to take a look at, and a caveat, this work is predominantly a brainchild collaboration between the Ripple Liquidity Hub director, Brad Chase, a former data engineer, Swapnika, and myself. We stumbled upon Data Build Tool back in 2020. And if you're not familiar with DBT, I'll skim through it at a high level so we can all be on the same page. Uh, so DBT essentially is a programmatic build, compile, and testing interface that allows you to interrogate your models prior to deployment and execution of those transformations that you would conduct in your SQL data warehouse. So some data warehouses like Snowflake and BigQuery, they do provide some capabilities of similar to this out of the box, but let's ignore that for this presentation. Um, the underlying issue is that the raw data gets loaded in a really, really messy way and can end up with lots of duplications. You need to do some joining across different silos, or you need to introduce just multiple transformation steps. Um, Prior to DBT, what we were doing, we would check in the GitHub. Um, these models, we'd run them and test them locally. There wasn't any automation testing framework. Eventually, everything was being tested manually. Documentation was produced manually. Refreshing dashboards was manual, and scheduling these queries was handled through cron jobs. Um, so you can look at DBT as essentially the T in an extract, load, transform model. It doesn't extract or load data. That's done by different processes in-house that I'll talk about in just a sec. But it's good at transforming data that already is loaded into your warehouse. And the tool that's been gaining a lot of traction is the DBT Cloud and also the DBT CLI. It's been integrated, and you can find interoperability with a ton of different SQL data warehouse like Snowflake, like BigQuery, which is our data warehouse, and other ETL frameworks like Fivetran. Um, it's very similar to Airflow as well, but it's targeted for a completely different data engineering team user. So this is targeted for the database analysts or the data scientists. And then it allows you to generate these documentations that could be coupled with your models and then also produce a lineage graph. So where does this sit inside the ELT, specific to Ripple? So again, we said the T is where the DBT sits, the transform. In the case of Ripple, let's say our data source is payments transactions for on-demand liquidity, which is pulling from the ledger and getting dumped downstream into some sort of data store, data lake. We connect things like, Fivetran, Stitch, Meltano to pull our data from APIs that are public, and we dump them inside uh, a data lake. But then we utilize our in-house processes to go ahead and ingest that into BigQuery. DBT comes in as conducting the transformations to build new materialized views that we could join that raw data for our compliance, our business consumers, or end users. And this essentially just shows a more improved display of what I mentioned. So again, some data warehouses like Snowflake, BigQuery, this does they provide capabilities like this out of the box. But the punchline is here: the raw data that gets loaded can be messy. We want to do some transformation to it so we can hit our BI tools. And here is just a few snippets of how it would work. So we're installing dbt CLI, which is the open source version. And there's two main files that you want to configure. So you'll have your dbt profile. This is a YAML file that identifies the environments, the connectors, the access tokens, the limits, the thresholds that you're enforcing on your SQL data warehouse, and then also um, things of like the staging mechanisms that you would also be doing from your method. So on the bottom, you'll see that we have our quick sample snippet of our profile for our staging environment. And then the models are just SQL files that contain the transformations, and or it could just be like a select all command. And that contains a config file with the SQL statement that you're looking to execute on BigQuery. These additional things that we can add into this database DBT kind of like landscape, like testing, like documentations, but these are the two core functionalities of it. Okay, cool. So this is great to go get working on my local machine, but how do we build the appropriate checks and balances to assure that we're able to collaborate as a team for new incoming DBT? So this comes down to the orchestration of DBT. So we need to orchestrate using some sort of GitOps mechanisms to conduct how the models are tested prior to being executed in BigQuery. So again, the transformations are going to be run on the compute resource of BigQuery, but the testing and interrogation of the model needs to be done on a different compute resource. So how costly are they? Do they represent the right schema for our staging environment? How do we get this into production? Well, we need a compute resource to test and compile. So everyone has their own profiles inside their laptop. We need to shift that over to a shared resource compute for compute. We also need a central way to manage and configure profiles securely. So gated approvals, tokens need to be obfuscated. And we also need to have some sort of gated mechanisms between staging and prod. We need compute resources to build, compile, and test the models. So this is a bit redundant of the first point, but it's really we want to just land that changing the thread configurations and the compute resource needs to occur prior to the Airflow. We also need an efficient way to schedule and execute the models. So maybe we could use something like a simple cron job to execute these models on a VM or a node machine. And then we also need the ability to clearly define lineage and define dependencies while managing them. If we deploy into a runner like on GitLab or a machine that's running inside our CI/CD pipeline that we'll get to in just a sec, DBT should get its own silo with its own Python dependency so that we can lock it into the version that's being utilized within our repository. So CI/CD, it needs to be smart enough to be able to roll back. It needs to be version controlled, and it needs to be collaborative. So I kind of did a misdirect by talking about cron jobs, but that was on purpose because there's a ton of tools that are being utilized for scheduling and orchestration of jobs. But since we already utilized Airflow, this made sense for what we needed at the time. So the caveat here would be utilizing dbt Cloud actually alleviates the ask for orchestrating this and minimizes some of the work. But since we're using dbt CLI to be cost effective, we have to do a bit more work, right? But that's fine. So if you're not familiar with Airflow, Apache Airflow, it's a workflow engine that you can schedule and run, complex data pipelines. It allows you to use operators that could call and connect to different third-party sourced operators, so you could connect to things within GCP or within AWS, like BigQuery, like Dataflow. And if you recall the ELT model that we mentioned prior to this, this is the extraction and load portion of that ELT. And we currently use it. So it makes sense for us. It's Python based, which is great for our team. And it allows us to monitor the status of individual tasks in an organized way. We can also rerun those tasks when they fail and monitor the DBT models in specific timeframes using the Gantt charts on Airflow. So, yep, this is just adding a bit more context. There are other options outside of Airflow. We think it's a great solution for us with dependency management, open source, automates access and connectivity to our GCP resources, which is really important. So we don't have to manage the tokens of who has a particular key to authenticate against our resources. This is handled within GCP, and it's version controlled and scalable. So one thing that makes our Airflow scalable is that it's a managed version of Airflow called Cloud Composer. This essentially just is a proprietary image that Google provides or produces that scales the resources underneath based on performance targets and metrics that you provided. Underneath the covers of Airflow or underneath the covers of Cloud Composer, in this case, is just GKE, which is Google Kubernetes Engine. And it enables us to have the flexibility with our deployment of dbt. And our use case, Airflow calls Dataflow. It calls the cloud Dataflow for our ETL. And then that ingestion of data gets loaded into our reference table in BigQuery. It's raw, but then the transformations occur afterwards. So great, we have our target Airflow that we're going to run dbt on. We also want to start embedding some CI/CD. So to ensure the quality of incoming features, the team essentially sought a way to create a pipeline that automatically validated those features for the models, and then we're able to build them with interoperability with existing features. So this is a pretty standard DevOps requirement. And to achieve them, our team implemented a CI/CD approach for our data applications in GCP. So to walk through this, as a developer, when I introduce a code change, I want to run a pre-commit script that enforces linting, for example. This is just syntax policies on the developer machine before it hits the server, the host. And then we push the merge request. Then we can validate it with some sort of Python validation, since we're using dbts in Python, Airflows in Python. And then we can use the builds that are generated. So we're targeting in the GitLab runner. We could have targeted Cloud Build, which is another great orchestration engine for GitOps and CI/CD. But at the time of implementation, there was no interoperability with Cloud Build and GitLab. So we used the GitLab Python runner natively and then connected our tokens directly to cloud storage. So this cloud storage is what Cloud Composer pulls its DAGs from and populates that inside the Airflow scheduler. And Cloud Composer go ahead and executes on that. So just a quick double click into what the pre-commit framework is. It's just a script that you run local to your machine that you enforce on local machines. You can run Python standardizations like BLACK, Flake8 to check the entire repo to make sure it's formatted before it comes into the merge request. Once passed, then the commit is added. However, for our dbt models repo, we can package the entire repo as a self-contained container. When we submit a merge request to our dbt repo, so this is our dbt repo versus our DAGs repo, this is our Cloud Composer DAGs. our DBT repo has our models, our tests that we want to package into an image artifact. So once the image artifact is generated, again, this isn't running any of the DBT methods or commands because it needs access to BigQuery or it needs more scalable resources, not just a GitLab runner. We push that into one of our registries to be pulled down into our Cloud Composer, right? So the dev image gets pulled into the registry, gets pushed into the registry, gets pulled down into Cloud Composer, and then we can execute our DBT commands directly there. And this is, friendly, user friendly for both the data engineers and the data scientists. They're designing their models. They're being able to push and iterate into the DBT models repository. Once they push their new image after it passes its build, they're able to directly see in only the dev environment if their model is passing, and then iterate on that. Once it passes the dev, they can, get a gated approval, push that over to the prod registry, and that gets pulled down into the prod cloud composer once that's been submitted on merge. And it's a dance between the data engineer and the operations tools. So they add the model. Again, you can see that there's a build of the Docker image that has the DBT uh, 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 artifacts inside of it. Once the model is built, it gets pushed into the GCR registry, or it could be Artifactory. It could be public. It could be Docker Hub, right? But then inside our Cloud Composer DAGs repository, we have more of a pre-flight. We're testing the interrogation of the DAGs. We have some quality assurance validations. We have some unit testing on some of our DAGs. And then this is just deploying our DAGs folder into the Cloud Composer Google Cloud Storage bucket, right? That gets, ingested into or gets scheduled by the Airflow scheduler, and then they're able to identify if there has been any failures that occurred within the deployment. So you should be scratching your head a bit because I did skip a step. How does the Airflow pull my DBT image and schedule it to be ran on BigQuery? So that's actually handled by an operator called Kubernetes Pod Operator. So operators, again, are just connectors with some built-in um, third-party extensions that you can utilize with its own code that's open source to enable you to add more functionality into the types of tasks that you want to be able to complete. So one task that we could have explored utilizing is actually the bash operator, which would pull the model directly from the GitLab repo and then just run and execute it instead of deploying it as an image, instead of deploying it as a container into a registry. Why couldn't we just grab the model to a direct model from the repo, git clone, run the model, and execute it inside Airflow DAG? That can cause and generate some dependency issues and conflicts within the packages. So Airflow has its own dependencies for the DAG. So if there's a Python collision or a package where DBT, that the one that we're mapped to inside the DBT repo versus what Airflow is mapped to, we can avoid that actually by using a Kubernetes pod operator. That allows us the flexibility. We're able to build images of the model and push to a common repo. We could push the images into our registries. It's self-contained. The dependencies are able to resolve itself because it's being deleted and terminated on completion of a task or on completion of a job. And then we have the option to scale dynamically on the workload. So here's a snippet of code. The image is a Docker image path, right? So this could be, again, the uh, Docker Hub image, or it could be a GCR.io path, which is a Google Container Registry uh, uh, URL. So if you want to go directly download from a container registry in GCP, or you can use Artifactory, Azure, AWS. But this is the command that we get to execute, right? So this is what's going to be the differentiating factor between what we utilize on our different DAGs. So this DAG is calling a specific model. It's called test payment. And then we have our environments that we're targeting. We can add additional commands. We can add an additional pod operator that does a test. If that task fails, then we have that level of monitoring and visibility into when that task has been completed or failed directly inside the Celery um, um, uh, Gantt chart that we can use from Airflow. And the last three things I want to point out here is actually the image pull policy, which is also an interesting configuration. This actually uh, prevents caching of an image. So if you are, pulling the image and you're doing heavy testing, you want the image to be pulled down directly every single time so that Airflow doesn't cache it locally within the node pool or the node cluster in GKE. And this enables you to pull the correct image. The last thing that we could target is the affinity group. So this is the node pool affinity, which I'll talk about next. So the node pool affinity allows us to target different resources based off of that affinity group that we specify in this configuration. So just as we identify that we don't want the packages for Python to conflict with the Airflow dependencies between dbt and Airflow, we also don't want the resources to conflict between Airflow and dbt. So in this, we are creating a new node pool, right, called dbt pool. This has 3 nodes, so we know that we're able to, have its separate own set of nodes. We could identify the machine type, the image type, and then at the moment right now, for testing purposes, I did not enable auto scaling, but if I needed to for a prod environment, we can. And so this is what it looks like, the final architecture. We have our data team dbt models, which is pushing to our container registry. When that gets pushed, after being built from our GitLab runner, we pull it into a Dev Cloud Composer environment on Airflow using the Kubernetes pod operator, right? And the Cloud Composer is responsible for 2 different sorts of jobs. We have our regular dev data flow ETLs, so ELTs. So this is handling the regular scheduled jobs that we're using to populate the data, the raw data into BigQuery. That's being handled by Dataflow. Let's say that's node pool 1. On node pool 2, we're doing the transforms, right? We're testing the integrity of the models that we're looking to, produce and deploy. And then once it gets, it passes its prior steps inside the pod operator task, we can go ahead and execute it directly on BigQuery as a dbt command. And then finally, we can do some sort of validation and, test the BigQuery for data quality, right? When this all passes, then we're able to promote it into our prod or staging environment and do the same thing all over again. So, for final thoughts and discussion, there was one thing that we didn't necessarily explore, which is the tracking and data lineage. This wasn't configured, but we do have the opportunity or the option to explore that even further. There is tools that dbt provides out the box. There's also other tools like Datakin and Open lineage that allows you to kind of utilize these new open source tools to start integrating that with DBT. We also have the choice of materialization at various levels. So for this example, we can do materialization views from the DBT pods into iterative views, so that it's constantly checking before it rolls into a brand new table. We also can improve security, image hygiene, and integration testing. So at this step of the DBT models, when we do build, there could be some more interrogation to assure that prior to deployment of dev and onto resources, we could do some soft checks and maybe some basic checks for the model to confirm that they're able to validate, like a SQL linting check. That's something that we can introduce inside our pre-commit framework. And then monitoring and alerting. So right now we have one sort of view when it comes to the failures of DBT, and that's typically occurring or being provided by the Gantt chart through Airflow, right? How do we aggregate that? Is there a way we can, consolidate some of our views and alerting? You can introduce here a Slack channel or SendGrid operators, so that when things fail, you can send emails to certain groups or certain channels, so you can enforce that based off of the environment, like staging or prod. Those are other options that we can introduce for failed DBT runs. So I'll stop right there and leave it open to. Looks like we have a ton of time, but I think I flew through it. Happy to go through any other parts, but leave it open for any questions that are on the line.
Yep. Thank you, Nathaniel, for this insightful session. So before we move towards the closing and award ceremony, we do have some time for the Q&A session. So for those of you, if you have any questions, feel free to use the question box that you see on the right-hand side of the screen. Type those questions down, and then we can have Nathaniel to answer those questions. Okay. So let me start with the first question first. So we have that question: can this DBT profile also be used for streaming data? Nathaniel?
Yeah, streaming data. So that parallelized processing probably wouldn't be necessarily good for that. In that sense, I would have to check to see if they've added maybe like new features, but I haven't necessarily seen it used for streaming data. Good question though. Good question. I mean, streaming data, you're typically using your Spark, right? Your Apache Spark to handle that, or Databricks.
Yep. Okay, thank you for that, Nathaniel. So if we can move on to the second question that we see, right? We have that a second question. What is the performance improvement of using DBT compared to other methods? Sorry.
Yeah, so this was automation, right? This was allowing us to centralize what we typically would do when it comes to interrogating our data models, right, into one particular tool. And it's open source, right? So when you're saying performance improvements, we're able to enforce, especially for data scientists who are sitting in Jupyter notebooks all day, or data analysts, even business analysts, right? They're all utilizing this tool because they have some sort of SQL requirements that they're looking to investigate and explore, right? We're giving them the platform to be able to almost act like developers and produce and submit that into a Git repository. Even if it could be a Jupyter notebook, it's still a Python script for the DAGs, and your SQL files could sit as their models. Then their YAML files define the configuration of what they want that DBT execution to conduct, right? Or execute. So performance, and compared to other models, it's just consolidating what was absent before. We were manually doing things.
Okay, thank you for that, Nathaniel. Let me check if we have another question. Yep, we do have another question. So how does Ripple use this? Does it have specific application for blockchain?
Yeah, so this is analysis of payments and transactions from the blockchain, right? This is a good connectivity between Web 2 versus Web 3. Still we're using Web 2 for analyzing data. So we do have clients and customers like anyone else, but they're using the blockchain for their transactions and ledger, which is all public data, right? We ingest all those transactions into a centralized place, right? And we want to be able to provide more insights to optimize how our customers are leveraging the payments platform or liquidation platform.
Thank you so much, Nathaniel. Let me check. We have any other questions? I don't see any questions here. Any last minute question from any of you? Oh, we do have one more. So how do you resolve the issue if there's a bug in the data warehouse?
Bug in the data warehouse. So you're saying like, hey, a bug was introduced, it got pushed all the way from dev to staging to prod, and we need to resolve it? Is that the question? Because now we have version control, right? So we could kind of roll back. And if you have your, geo redundancy and data policies around BigQuery, you could just have a snapshot or a capture that you could roll back to for that as well. So we roll back our Airflow and we roll back our DBT versions because that's source control through GitLab, right? And then we revert back our data, BigQuery, our SQL data warehouse back to a previous state.
Okay, thanks for that. Any last questions? No? All right. And with that, Nathaniel, I'd like to take this time to thank you for joining this event. Thank you so much. Take care, and I hope to see you again. Thank you.
Thank you. Take care.
Yeah. So for the rest of the participants, we do have one final session, which is the award and closing ceremony. So don't miss out on that because we do have a few important points that we'd like to share with you. So in another 25 minutes, please join back the session. Okay. Thank you, and I'll see you again.